So this is my second video, continuity of the other one, the one that I introduced on stereochemistry and conformation. So I'm going to be talking about conformation further. And when we talk about conformation, we are talking about 3D, and it can be about acyclic compound, which is this one. Acyclic meaning that it's not in cyclic form, or cyclic compound, which is, for example, this benzene ring and this cyclohexane ring. Okay, when I don't want to put it in 3D form. What I need to do is I need to use what we call wedge and dash. Okay, so the wedge is, have you seen potato wedges before? So this is about the form or the way that we write it, like a potato wedges. Another one is we call dash, is like this. Okay, so this dash, when you see it like this, meaning that it is away from you, because it is a little bit showing like it's fading. So this one is showing solid color because it is towards you. So this is telling you the towards you is near, the one is with dash is away, which is further away from you. So when we look at this, if I write it this one as wedge, meaning that this particular hydrogen here is actually pointing towards me. Okay, and when I change this as wedge, okay, I'm showing this particular hydrogen is actually away from me. So if I have this 3D, this particular two hydrogens now is behind the whiteboard. Okay, you have to use your imagination. And this one, which is as usual as we always write, this is showing you that it is in the plane form. So you have three particular types of writing, which is wedge, towards you, the one which is solid, dash, fading, which is away from you, and plane. Plane is on the board itself. Okay, I hope you understand. So when we talk about conformation, we are talking about, as I said, temporary molecular shape that happen, to changes that happen for this compound temporarily because of the rotation at one bond. So I'm going to be talking about the rotation at the bond of between carbon and carbon. So if I write this carbon as A and this carbon as B, so I'm going to be talking about the rotation of this particular bond between carbon A and carbon B. Okay, and before that, before I go on with the rotation, I need to explain that we can write this particular compound, the 3D compound, in a few forms. And the forms are called, one is Newman projection. Another one is called Sawhorse. Okay, so this is called Sawhorse formula. Okay, now the famous one that being asked most of the time is based on the Newman projection. So this is what we call conformation form. Okay, and to tell you about the 3D or the what do you call that, arrangement of this hydrogen, I use wedge and dash. Okay, so that you can understand now, the one that is solid is towards you, the one which is dash is away from you, the one which is plain like this is actually on the board itself. Okay, let's talk about Newman projection. Okay, Newman projection is when I rotate this particular compound and I look at it from a point. So Have you seen seesaw before? You know, at the park, you can see seesaw, and then when we look at the seesaw, at one point we can see it like this, isn't it? Okay, so this is sawhorse. Sorry. This is sawhorse. Okay, this is sawhorse formula. Okay, so now I'm looking at this compound from a point, for example, this point. So this is actually representative of Ca, and this is actually representative of Cb. I hope you understand that. So I'm coming back to you with new moon projection and further on with sawhorse.